Hello everyone, welcome back to the channel. In this is going to be our last video for this series. This is the last topic that is left to cover. That is recursion in Python. Okay, so in the last video we have discussed about functions, how functions work, what are functions. We just did everything about functions in depth in the last video. Today we are going to cover recursions properly in depth and like properly we are going to do as we have done the other lectures, like doing the program practices, examples, real life examples, and theory part also. So we are going to do all of it in this lecture. So after this you can say that you know Python. Okay. First is introduction. What is recursion? So as I told you that but when a function calls itself is no it directly or indirectly will be known as recursion. And why do we need to learn it? Because like we don't need to write that thing again and again. It will improve the readability and it will make our code more efficient. Okay. Like in organizing your data, it is very useful in that. Okay. So what is the difference between recursion and loops? So as we did in the lecture of loops, that loop is something like basically repeating something again and again, and we don't need to write it again. So basic difference between loops is like loops repeat a specific action. They reuse the same block of code again and again. But recursion repeats the action by creating that new copy of the function that was on the top of the memory. Okay, so what is recursion here? Self-referencing function. As I told you that the function calls itself. So this is it is a referencing to itself. To solve a problem by breaking it into small pieces, like it breaks it into small pieces and then it runs it calls itself. Okay. Base case, the condition that tells the function when to stop. Prevents infinite loops. Like in the loops also we had this thing that we use break statement for breaking the statement, like if it is going to infinity, it has no end. So we don't want the loop to run again and again to infinity. For uh, for avoiding that situation, we have this base case thing. In loops, we have break statement thing. Here we have base case thing. It will tell the function that when it is supposed to stop, it is going to infinite loop. There are two cases under recursion. First, base case. Second is recursive case. Base case is when it is going to stop. It is going to tell to the function. And recursive is like the part of the function where the function is calling itself. The part where function is calling itself with a simpler version of the problem. Okay. Why do we need to learn recursion? So, what's the need to learn recursion? Tree and graph problems. It will be easy to solve tree and graph problems. File systems, the DOMs, the and decision trees are all recursive by nature. They all are recursive by nature. So it will be easy to assess them if we are using recursion in there. Okay. elegant readable code. The code that will be writing will be elegant and readable. Certain algorithms become dramatically cleaner, easier to understand because it is going to just make a code short, or we don't need to write it again and again as we need to call it. So it is easier. It is basically making our code easier. Power, power through real systems. So search engines, compilers, and databases, all of these things will rely on recursive algorithms under the. So as these all things are relying on this recursion, so that is why it is required for us to use recursion. So here the difference, or we can say uh, a comparison between recursion and loops. So what are loops? Here it is like told with the help of a flowchart, something, a diagram. So here loops code repeat code while condition is true. If the condition is coming out to be true, it is repeating. When the point comes where the condition is not coming out as true, it is coming out as false. At that moment, it is going to make itself false. It is going to stop itself over there. So this is how loops work. You use when steps are uniform, best for simple iteration, like that. Recursion. Function calls itself with a simpler input. Function will call itself with a simple input. Okay, it is using a more simpler input to call itself. And it is used for divide and conquer. It divides and conquers. Okay, best for nested and tree structure. When we are having nested and tree structures, like one thing another is inside that thing, like nested thing that we know now. We have nested things a lot. Like one thing is containing the other thing, like that. So nested and tree structure, the coding is really helpful in nested and tree structures. So both loops and when to choose recursion, that is telling us the condition and the situation when we have to choose recursion and when we have to choose loops. So here, both the key differences given over here. Both loops and recursion solve repetitive problems. Whenever the problems are coming repetitively, at that moment, it is recursion that recursion and loops both that help. But when, how do we identify that when we need to use loop and when we need to use recursion? Let's say loops repeat a block of code while a condition holds true. Loop will only work when the condition is coming out as true. Once it comes false, it is going to stop over there. But recursion reduces the problem to a simpler version of itself on each call. As we call the function, we call the function, it is going to make that smaller and easier, simpler version by each call. Okay, so recursion shines for divide and conquer problems that split naturally into sub problems. So divide and conquer. Divide means it is just dividing, it is breaking out the problem into smaller, and it is splitting naturally into sub problems, like it is dividing and it is conquering by solving that problem. But after dividing it got easier. That's how it is conquering it. That's what it is meant here. Rule of thumb: if the problem has a recursive structure like a tree, use recursion. If it's counting, use a loop. Okay. If you have a structure like tree, then use recursion. And if you can see that it is counting, then use a loop. Here, see, here's the statement, here's the true thing, here's the false thing. Even if it's true, it's working, it's like breaking or down. And even if it's coming false, it is breaking down. But in this, if it only runs for the true statement, if it is coming false, then it is not running itself over there. Okay, so just remember for recursion that it divides and conquers, and the loops only run for whenever the condition is coming out as true. If it comes false, it is not going to run. Whereas theory, like the two essential parts is base case and recursive case, the call stack, how Python manages recursion, how recursion is managed in our Python code. So that thing is the call stack. Factorial example we will give here, and common pitfalls, that mistakes that you need to avoid in order to learn recursion. So the two essential parts, that are base case and recursive case. So as I told you, the base case is that stops the function from repeating till infinity. Okay. So this is the condition when the function will know when it has to stop itself. Without it, the function will call itself forever, crashing with the stack overflow. So there will be a stack overflow if the function keeps on calling itself again and again till forever, like infinity. So that's why we need to have a base case to stop the recursion at some specific point. Okay, recursive case, the step where the function calls itself the progressively simpler input, moving towards the base case. Sorry. So it is the step where the function will call itself the specific line, we can say the specific part of the code where the function is calling itself and it is moving, like it is getting simpler and simpler as in, with each call that you are making to it, and it is moving towards the base case. So here are two examples given over here. They, like, if n is equal to 1, return 1, return n star factorial and minus. So this is a part of one code only, when where you are trying to find the factorial. But the part of that code, this part of the code is recursive case, and this part of the code is base case. Okay. Missing base case will lead to infinite recursions, and Python will crash with recursion error. It will show you an error that is known as recursion error. Always define your stopping condition first. We need to define the stopping condition first using our recursion. So how the call stack works, how we are just calling it, how is it working in Python? So every time you call a function, Python pushes a new frame onto a call stack. It pushes a new frame to it. The call stack that we have made by calling again and again, it uh, pushes a new frame to it. When the function returns, the frame is popped off. When the function will return again, that frame will be popped off of the stack. Okay, each recursive calls add a frame to the stack. The more you call it, the more stacks you get. Adds a frame to the stack. Okay. The stack grows until the base case is reached. The like you are stacking plates, okay, one over another. So you are stacking the plates, and you want that to be stopped at some point, right? Like you are just building the stack with the plates, and you see that at after a point, if you put one more over there, it is going to fall and everything is going to collapse and break. So at that moment, you wanted to stop at some point. You can't just go till infinity, right? So this is how it is working. Each recursive call, like you call the function, so you put one plate. Okay. So the point where it comes where you can't stack one more, even a single plate more over the stack, that is the base case, that you can't go over that. That is where the condition is met, you can't move further. So see, the stack grows until the base case is reached. So it will go to the base case. When it is reached, then it is going to uh, uh, it is going to stop. Okay, then the stack unwinds, result bubble back up one by one. When the stack is like open, it unwinds, then the results will come back one by one. Think of it as a stack of plates. You add plates going down and then remove them coming back. That is what I just told you in the example. So here is an example given related to factorial. Okay. So here, like, calculate factorial of 5. I want to calculate 5 factorial of 5 first. For like recursion is a type of function only. So first you write diff diff this def that defines function. Then you wrote factorial and n. And then you wrote the condition, if n equals to 1, return 1. Then you for under this you wrote return, like if this condition is not met, then return n star factorial n minus 1, print factorial 5. Okay, so the function reduces n by 1 on every call, working towards the base case n equals to 1. So here you have written return n star factorial n minus 1. See here, the n here means 5 because we just wrote here like this. We called the function, right? Here you just mention a condition that when n reaches 1, return 1 means stop over there. That is the base case that you have specified. Here, let's suppose you took the n's value 5. 5 star factorial 5 minus 1 is 4. Okay, it did like this. Then it is going to just uh, go one step lower. Now it's 4, 5 is done, then it is going to 4, then here will be 3, then 3, then here will be 2, then 1, 1 minus 1 0, and n's equal got 1. There is the base case and it is going to stop itself over there. All right. So let us just try this one example in our online compiler here. So the first thing we write is def factorial and n. Okay, then we wrote return, oh sorry, if n double equality 1, return 1. Okay, then we again got here return n star factorial n minus 1. Then we go here, print factorial. Let's suppose I want to find factorial of 4. 24. Okay, And let us find it for some other one. Like I want to find it for 5. See, the output was already given over there. It was 140 or 120, I guess. So let us run and see. 120. Okay, that is how it works. Okay. So winding, base call, and unwinding. That is how recursion is working. First is it is winding by calling the function again and again, like it is stacking. Then the base call, when the base call reaches, then it is removing the plate one by one. Just the stack of plate. First, you started calling the function. The more you call the function, you stack one plate on another. Then you're stacking, then at one point the base case came that above this you can't go, and at that moment you just start putting the plate down one by one. Every recursive function goes through these three stages, that is winding, base case, and unwinding. Understanding the winding and unwinding of the call stack is the key mental model of recursion. So for building any model that is using recursion, you need to know this thing, that base thing is winding, base call, and unwinding. You need to know that when the winding and unwinding of call stack is done, that is the key thing that is used in recursion. If you don't know this, then you can't just build a recursive model on your own. So here are some common pitfalls, common mistakes that everybody makes basically in recursion. So here is the missing base case. If you forgot to specify your base case, then it is like I told you, it is going to show a recursive error. Recursion error is going to show that it is like running till infinity. So for that, it is this is the error that mostly everybody makes, that is you forgot to specify the base case. So the most common mistake: without a stopping condition, the function will call itself forever until Python raises a recursion error. And some wrong base case: if you specify the wrong base case, that a base case that exists but returns an incorrect value silently corrupts all results. If you specify the wrong base case, then it is going to automatically going to corrupt all the results, and it is going to make your uh, this whole code wrong. So the third one pitfall is recursion 2D. Python's default recursion limit is like approx 1000 calls. You can only call a function till 1000 times. Okay. If you go after, like beyond that, that may not be possible in Python. For large inputs, consider iterative solution like this: SYS set recursion limit. Like here you can set the recursion limit, or use a memoization or to reduce call. Okay, so you can reduce the call, the number of times you are going to call, you can reduce that, but you can't go beyond 1000 calls. Okay, so these were the common pitfalls that most people make, mistakes that most of the people make while writing our this recursion code. So here are the learning objectives.